All right, so let's apply it again. I think you're probably still a little bit fuzzy on exactly how to do this, but I think after this one, you'll start feeling a lot more comfortable about what it is that we're doing. So to determine the confidence level on the mean weight of filled buttercups, 40 samples are measured and found to have a mean value of 8 ounces and a standard deviation of 0.2 ounces. So what do we know? We know that the sample size is 40, so that means n is 40. We know the mean is 8, and we know the standard deviation is 0.2. Determine the confidence interval on the mean weight of buttercups with confidence levels of 90, 95, and 99%. So we're going to do this 3 times in a row with each of these, all right next to each other, so you can see the process. First, I'm going to do the 90% level 1, and then you will do the next 2. For 90% confidence level, the first thing I got to do is find the white tails. So that would be 1 minus 0.9, which is 0.1. And then I've got to divide 0.1 by 2 for each of the 2 tails, and I get 0.05. So that white tail area is 0.05. What do I have to do next? Well, the next thing that I have to do is figure out what is the z-score associated with that half white tail area. To do that, I always go with second bars. I keep it in z-score mode, which is the 0 and the 1. Second bar's inverse norm is 0.05 with a mean of 0, an area of 0.05, sorry, a mean of 0, standard deviation of 1 for the purposes of working in this mode. And I get 1.645. Good. Now I got to start talking about my error bound. Now the error bound is always the answer to the second bar's inverse norm, the area, the z-score for the area cut in half, and then the standard deviation divided by the square root of the sample size. So that's 0.2 divided by square root of 40. When I do that basic calculation, I get 0.052. So up until now, I needed to do the work on the first line that says 1 minus 0.9. And then the magician in the calculator waving around that calculator wand and waving his hat around and everything else does the second bar's inverse norm. And they do the error bound calculation by pressing buttons on your calculator. Now you need to know what to do again. You need to realize that the confidence interval is going to be the mean, which we said was 8, minus the answer to the EBM plus the answer to the EBM. So I get 8 minus 0.052 is 7.948, and 8 plus it is 8.052. So I could state that the 90% confidence interval is from 7.948 to 8.052, and make sure that you are in parentheses. Okay, so I went through the 90% with you. Let's see you do the 95%. Go ahead. Don't mind my dogs barking. I think my wife stepped outside to get the mail. Go ahead. I'm sure you're using stop and start, but if not, do so now. And here's the correct answer. For the 95% confidence level, I'm going to do 1 minus 0.95. That gives me 0.05. Then I have to divide that by 2 for the 2 white tails, and each of the white tails is 0.025. Okay, excellent. Now I have to do second bar's inverse norm to that 0.025 in z-score mode. That's the 0 and the 1. And I get 1.960. That allows me to use my error-bound measurement formula, which is always the answer to the second bar's inverse norm times the standard deviation divided by the square root of the sample size. So it's 1.960 times 0.2, the standard deviation, over the square root of 40. When that's done, I get 0.062. What do I do with that 0.062? I subtract it from the mean, the middle of the green area, and I add it to the mean because it gets me the 2 sides. So 8 minus 0.062 is 7.938, and 8 plus 0.062 is 8.062. That means the 95% confidence interval is 7.938 to 8.062. I just want to take a look at one thing real quick here. Doesn't it make sense that the 90% confidence interval level here should be close to the 95% confidence level interval here. That to me suggests that we should be pretty confident that that our mean is going to be correct. Okay, let's do it again for 99%. Go ahead, do stop and start. Yeah, and the answer to this should also be pretty close to the answers to the others. So, look, can you see on the screen that it's the same exact steps for 90% and for 95%? And that basically the only thing that changes any numbers in here is you're starting with 1 minus 0.9 here, and then for 95%, it's 1 minus 0.95. So for 99%, it's 1 minus 0.99. That's 0.01. There are two such areas. I divide it in half and I get 0.005. So the whitetail area is 0.005. Okay, well, that's great. Now let's do some second var's inverse norm to 0.005 and 0.1, and that gives me 2.576. All right, now I can calculate my error bound. 2.576 times, again, it's the same thing, standard deviation over the square root of the sample. So 0.2 over square root of 40, and I calculate that. Again, it's pressing numbers. The magician finds the second var's inverse norm. The magician finds what the buttons pressed on the calculator comes to, and you get 0.081. Now you get back to work. The way you get back to work is you say, okay, now I got to subtract it from the mean and add it to the mean. So the only work you do is the first part, which is really simple. And the second part, you got to remember to subtract it and add it to the mean. That gives me 7.919 and 8.081. So the confidence level for 99% is between 7.919 and 8.081. So that is the process applied 3 straight times in a row. Okay? Now, there's one other way that we could possibly do this, and that's where you have the lucky job of figuring out the mean. And what's the easiest way to figure out the mean of these numbers? Well, the really cool thing is your calculator will do it for you. So you could add them all up and divide by, in this case, I believe it's 30, or you can let the calculator do it. Let's take a step back, read what the question says, and then show you how the calculator can do everything in this problem, soup to nuts, except the same 2 steps you're always responsible for: finding the area of the white tails and remembering to subtract it from the mean and add it to the mean to get the confidence interval. The specific absorption rate, the SAR, for a cell phone measures the amount of radio frequency energy absorbed by the user's body when using the handset. Every cell phone emits RF energy. Different phone models have different SAR measurements or values. To receive certification from the Federal Communications Commission, better known as the FCC, for sale in the United States, the SAR level for a cell phone must be no more than 1.6 watts per kilogram. Table 8.1 shows what we have. Okay, so here's a bunch of different phones, and here's their scores. If you want to use your calculator to do this, just go to, take your calculator, obviously turn it on, go to Stat, and then the very beginning is Edit. It says Stat Edit, hit Enter, and then lists come out. You want to enter all of your information in list 1. To clear out list 1, you want to go all the way up to the top, above the little heading bar at the top. Get your cursor in there, hit Clear, Enter. And then that little cursor jumps down below the bar. And that starts telling you what goes in list 1. And then I'm going to go down the column, starting with the Apple iPhone 4S. You do 1.11, enter. 1.48, enter. 1.43, enter. 1.3, enter. 1.09, enter. And you continue and put all of these scores into the graphing calculator, into that list. At the end, it'll tell you like L1 and in parentheses 31. That means that it's awaiting the 31st score. But you only have 30 scores, so you're not going to input a 31st score. But it's really cool that it says 31, because that means you have put 30 scores in. And since there's 30 scores on the screen, that means you didn't miss any, and you put everything in that you should. Then go to hit the Stat button again, and this time go across to where it says Calc, and then it'll say one variable stats. Hit enter, enter again, and it'll say X bar at the top. You know X bar means mean, and it'll tell you exactly what the mean is. Because, remember, of course, we want to find the 98% confidence interval, and the only way to do that, you have to have the mean, which is why for all of these values on here, these 30 scores, you needed to first find the mean. And to me, it's really cool when the calculator does that work for you, okay? It tells you, by the way, the standard deviation is 0.337. So we need the mean, we need the standard deviation, and we need the error bound. I think I typed that wrong. I think it's EBM. But anyway, the mean we just figured out. The standard deviation, it says, is 0.337. We also need the sample size to get the mean. And it says in here, the sample size. It doesn't say the sample size is 30, but there are 30 different cell phones listed. So you know the sample size is 30. Okay? The mean is 1.024. So when you did what I told you to do about putting all the values in list 1, okay, and then dividing, you could put them all in the table, divide by 30. You could do that. Or you could just enter them into list 1, and list 1 will give you the values. Now, we want a 98% confidence level, just like before. Step 1, the green area would be 98. So 1 minus 0.98 is 0.02. Dividing that into 2, it's 0.01. So the whitetail area is 0.01. Now I need to find the z-score associated with that. That's second bar's inverse norm, 0.0101, and I get 2.326. Great. Well, that allows me to go into the EBM formula. I always take the answer to my second bar's inverse norm. That's 2.326. And then I multiply that by the standard deviation over the square root of the sample size. It told us the standard deviation was 0.337. And it said the sample size was 30. So I get the square root of 30. That gives me 0.143. Okay, you finish it from here. Go ahead. Little stop and start time. Okay, so we know that the error bound is 0.143. So we also knew that the mean was 1.024. So if I do 1.024 minus the error bound, I get 0.881. And plus the error bound, I get 1.167. So 98% confidence interval is 0.881 and 1.167. As you can see, the step-by-step process for finding a confidence level never changes. Furthermore, the magician in the hat always does the tough stuff, steps 2 and 3 in the process. What are you responsible for knowing? You're responsible for figuring out the area of the white tail. That's just the green, 1 minus the green area, and then divide by 2 for the 2 tails. Then you're responsible for knowing that you need to add and subtract the answer to the error bound from the mean. That spreads out the green area, or represents the symmetry of the green area, the plus and the minus. And then you just make a statement that says, look, the 98% confidence level is, and you list your 2 answers that you just got before them. That process will never change. And with a graphing calculator, it's really not that hard. If for any reason you're still having a problem with it, go back and redo